Hi, my name is Victoria and I'm a Senior Development Team Lead at Atlassian. And today I'd like to talk about practical patterns for developing a cross-product, cross-version application. So first up, why am I here? For the last 2 years at Atlassian, I've worked on and then subsequently led the team that's responsible for maintaining the Atlassian Troubleshooting and Support Tools plugin, or ATST for short. Now, ATST monitors the health of your instance and helps users to identify and self-remedy issues. ATST is quite unique because it is bundled with all of our server offerings, and the updates and improvements to ATST are actually shipped regularly to the marketplace, where we encourage our users to update ATST out of their regular update cycle. So today I'll talk a little bit about the patterns that our team uses to ensure that for ATST, the same distribution can be run across multiple versions of the same product. I will then talk about how we develop cross-product features in ATST. I will also really quickly touch on DC feature development. And finally, if we have time, I'll open up the floor to Q&A. Now, developing an application that is able to run across multiple versions of the host product. Developing an application that continues to work after the user has actually upgraded the host product, it's important. Incompatible applications during an update is a large pain point for our users. The end user experience really improves if we can make sure that we develop applications that are resilient to these changes. Now, first up, a quick word on versioning as followed by Atlassian. Atlassian follows Semver in our self-managed offerings. And as you're probably aware, what that means is that for major releases, this is where we bundle all the new features and all the API breaking changes. Now, minor releases, they contain features but no API breaking changes. So what that means is that the API will remain forward compatible throughout all the minor releases within a major release family. Bug fix releases, they're really just for bug fixes, and they contain backwards compatible bug fixes. We try to be pretty good in that. I know, sometimes there are still changes, but we are very, very conscious of making sure that we do only put the backwards compatible fixes in there. Now, let's talk about our first challenge. Say I want to introduce a feature that will only show for the later host product versions. One way we can do this is we can build this on top of a feature flagging mechanism. Now, feature flags can be used to turn off features or subsections of your application on and off easily via configuration, example system properties. So here is an example, and we're going to determine if the My New feature is going to display only for versions of the host product that are newer than 5. So if you have a look, what we're doing in the should-display method is we're making sure that the current version of the host product, and this is the version at runtime, not compile time, is actually greater than what we want. And we're also making sure that our actual feature flag is enabled. Now, in Confluence and Bitbucket, we also have conditions that we can use that are provided by these products. Now, for Confluence, there's a build number condition. And for Bitbucket, there's an is application version condition. So you can use those to control your web items and things like that and resources. Now, let's take a look at the next challenge. I want to write my feature to be resilient across API changes. So what does that mean? So say we have an API provided by Jira API. This has a method, some method. I'm great at naming. You have a function in your application that utilizes some method that is provided by this Jira API. Great, wonderful, your application works, happy days. Now, change happens. And in some version of Jira, we've deprecated this API with a view that we're going to remove it, and we've replaced it by a shiny new useful method. That happens. Maybe shiny new useful method is performant, but more performant than the older alternative, but this is something that does happen. So how do you write your applications and your functions to make sure that you're able to handle both? Now, if you have a look at the my function here, if you simply just change it to use the shiny new method, now that's only going to work on your newer version of the host product. It's not going to work in the older versions. So one thing you can do is you can use tries. So you can make sure that you handle the fallback of this method not being there elegantly. I will note that obviously you can use reflection, but it's something that we really, really don't recommend you do. Because this is, if it bites you hard. Now, okay, look, try catches, this works, but imagine you're really using a lot of API, and you don't really want your code to be littered with try catches everywhere. So I'd like to talk about maybe a more elegant way of handling API changes, and this is something we call bridging. Now, this is a method that the Portfolio team in Sydney use to make sure that Portfolio runs across multiple Jira versions, and some of the examples that I'm including are basically from the team. Now, to build a bridge, the first thing you really need to do is organize your application. You need to create a very clear separation of concerns. So you need to establish what are you bridging. So at the moment, you've got your application does really cool things and it accesses the API. Now, what you want to do is you want to restructure your application to separate your business logic and extract all the direct API calls from the rest of your code base into a library. So it's going to start to look a little bit something like this. Your business logic should not have any calls on Jira APIs or any other product, or depend on them. So essentially, this is just your business logic. It shouldn't know that it has anything to do with Jira or any of our products. Now, the next is you have another class structure that does encapsulate these API calls. So these are the things that you need to get via API. Now that we've created clear separations of concern, next, we need to define, let's say, our bridge blueprint. Please, bear with me for the bridge analogies. I'm trying here. So to define your bridge blueprint, what you're going to do is you're going to say, this is the operation that we actually want to bridge. So in this example, we've got a search service bridge that is going to bridge the search operation in Jira. Next, we're going to build out a bridge for every breaking API change according to your defined blueprint. So we're going to be building all types of bridges. So here we have two search service bridge implementations, one for each Jira API change. So search service bridge 712 is the one that's going to have the 712 specific code, and search service bridge 74 is the one that is going to have the 7.4 specific code. Now comes the tricky part. We have to build a way to select which bridge should be used. And what I mean by this is we're going to rely on Spring lazy loading our beans, aka our bridge implementations, at runtime. But we have to create a mechanism for how these beans will be selected and provided. Specifying how to select the right bridge, in our case, we're going to be using version ranges. We will create a supported versions, a custom annotation, that we can use to annotate our bridge applications with. So this is the glue, if you will. This is, us building the glue. The logic to actually select the right bridge at runtime can look a little bit like this. So we can compare the host Jira version with the supported versions to select the right bridge. So it's important to note that you are actually using the runtime versions here. Don't go by compile time because you want the right bridge to be selected at runtime for you. So given the right version of the host product, you're now able to determine which bridge to use. So you've got a method, get supported bridge, you just give it the version, this is your runtime version, and out comes a bridge that you should be using. So let's put it all together. So first we've got our bridge blueprint, search service bridge. That's just our interface. Then we have our actual implementation. So this is our bridges themselves. And these we're going to annotate with supported versions. Now, a quick note here, we have to manage the namespace. To prevent collisions, we do have to make sure that we're using the @named annotation. So now, this is what your implementation looks like. You've got a do my thing. We access the search service, which is our bridge blueprint, and a provider, and say, hey, get me the right bridge. And that itself, all the logic to select the right bridge should be there. Cool. So this is how it looks like in terms of the actual project. So what your application begins to look like is, you've got your app, you've got your business logic, and you've got your bridge interfaces. Now, then you've got your bridges, which is version specific. And so those are the ones that are actually going to be depending on the specific versions of the API. Now, for example here, bridges 7.6, that's going to have a dependency on the Jira API 7.6. It's also going to have a dependency on the bridge interfaces. Now, bridges 7.12, it's only going to have a dependency on 7.12 and bridges interfaces. It itself doesn't know anything about 7.6. Now, all this is going to be bundled, and every time you're going to build a bridge, that actually just adds to your definition. We're not going to remove these bridges until we're no longer supporting versions. And now you're going to be relying on the right bridge to be picked at runtime. Cool. So some of the, hopefully now you've got some patterns that you can use to protect yourself against version changes in a product. However, keep in mind that if you depend only on API and not internal API or any other internal core classes provided by the host products, hopefully the scope of your changes and the impact that host product changes have on you is going to be more limited. Another quick note is you can also use something like the Maven Enforcer plugin to help manage and ban some transient dependencies. Now that we've seen a couple of patterns, let's talk a little bit about how we can actually develop cross-product applications. Now, here I've got the ATST product version supported matrix. So this is currently every single version that ATST is compatible with and every product. Now, even though we produce separate artifacts for each product, we actually do so from a single project. By keeping everything in one project, we're able to easier ship common features. If we take a look at the ATST project structure, we'll see that the ATST API and common libraries, they're actually product agnostic. The shared code goes there. Next, we rely on split module Maven projects to cater for multiple products. So all the Jira specific health checks and code go into plugin Jira. Now, plugin Jira will depend on Jira API and ATST APIs and ATST common. So this is also where we will build our Jira artifact from. Each product has its own separate folder to keep its product-specific code in, and separate artifact will be produced for each product. So you can see that since we're building the Confluence artifact from plugin Confluence, this will not have any knowledge of the Jira-specific code, nor will it have any dependencies, nor will it be bundling anything that is Jira-specific. So let's talk about how we actually introduce a feature to ATST. So since we like to ship value to our customers as soon as we can, and we do ship to Marketplace fairly frequently, we try to tackle a cross-product feature, one product at a time. So first we start introducing the required API into ATST. At this particular point, when it's in the API module, you can think of it as dead code. We're putting it in there so that we can start on the implementation. Now, if you're super lucky, you can maybe implement this feature in a totally product-agnostic way. This can happen if you rely on SAL, which is the shared access layer, or libraries that are implemented by every product. And in that particular case, we can just add our implementation to common. Now, more often than not, you will have some product-specific code, and so we will actually add the implementation in a product-specific way to the corresponding product module. If a feature is not required for a particular product, we include a no-op implementation. Now, just some general tips for cross-product development. Do take advantage of SAL, which is the shared access layer. These APIs are there to provide a consistent and cohesive API to common plugin tasks, regardless of the Atlassian application into which your plugin is deployed. SAL is most useful for cross-application plugin development. Use provided scope to actually use the host product libraries instead of bundling your own. This is also key. Now, also very, very quick note on developing applications for data center. Unfortunately, I don't have time to go into too much depth here, but I wanted to take a few minutes to call out some important things to keep in mind when you are developing an application for our data center license products. Now, I won't be talking about the DC Apps program. I think Ben Magro has a couple of talks coming up later today. But in terms of when you're actually developing your logic inside of your application, make sure that you are keeping the concepts of this is licensed for data center, or this is maybe only a feature that you want to provide in your actually DC licensed application, separate from the clustering available and clustering is active. So those are two concepts that at the moment are sometimes living on one and the same, but they're definitely something that we do expect to change, and it's something that we want to make sure that as we're building on our enterprise offering, we are going to encourage users to enable licensing in a different time than actually configuring their applications for high availability. Now, every time you introduce a new feature, consider if this feature needs to operate on a per cluster or per node. And this includes taking into consideration maybe caching and any scheduled jobs as well. And finally, there's actually some really good Atlassian documentation specifically for developing your data center applications. Cool, thank you.